Hi students, this is my third video of states of matter. In this video, I'll explain regarding Dalton's law of partial pressure and Graham's law of diffusion. Okay, coming to the Dalton's law of partial pressure. Suppose what this law says is, like when two or more chemically unreactive gases, if they are kept in one container, suppose if in a container if you have taken A gas, let it be A, and in another container they are kept B gas. Okay, yes ma'am, closed container. Let the pressure exerted here be PA, okay, and number of moles be in A here. Here the pressure exerted be PB, number of moles be PB. So what we are doing is, here we are keeping those two gases in the same container, as this is unreactive. So what is the pressure exerted by A? It's nothing but PA, okay. Pressure exerted by BB, PB, okay. And what is the total pressure here we are getting? Here we are getting total pressure as PA plus PB, okay. And what is the number of total moles here? Nothing but Na plus Nb, okay. And so we have taken two gases A and B. Let the pressure exerted by AB PA, let the pressure exerted by BB PB, the number of moles of AB Na, number of moles of B NB, okay. When they are kept in one container, the total pressure is nothing but PA plus PB, and number of moles is Na plus Nb. What is this one? So this is nothing but Dalton's law of partial pressure. So what it is saying, the total pressure exerted of chemically unreactive gases is equal to sum of their individual pressures. Is it clear? Yes ma'am. Okay. Coming to the proofs. Clear with this? The total pressure of chemically unreactive gases is equal to the sum of their partial pressures. Okay. Now, applying ideal gas equation. What is ideal gas equation? In PV equals to nRT. Coming to the PA. PA into V equals to, we are talking for A molecule, NaRT. Let it be a first equation. What is for PB? PBV equals to, say, NB into RT. Let it be a second equation. What is the total pressure we are getting? What is the total pressure we are getting here? Total pressure P, see here, PV equals to nRT. This P is nothing but what we can write, PA plus PB into V equals to Na plus Nb into RT. Yes or no? Why? The total pressure is nothing but sum of their partial pressures, and total number of moles be Na plus Nb. Now, what we are doing? Dividing equation 1 by equation 3. Okay. Divided, what you will get? PA into V equals to NaRT divided by PA plus PB into V. This is your equation 3, right? By Na plus Nb into RT. VV gets cancelled, RT gets cancelled. So what is left over here? PA by PA plus PB equals to Na by Na plus Nb. Okay. What is this PA plus PB? Nothing but total pressure, right? Capital P equals to, what is this one? Can we write it as mole fraction of A? Okay. So partial pressure of A equals to mole fraction of A into total pressure. Okay. Similarly, partial pressure of B equals to mole fraction of B into total pressure. Yes ma'am. This is your final formula. Or else simply we can write mole fraction equals to partial pressure of gas by total pressure of the mixture. Okay, now coming to one problem. See here. For 450 ml of nitrogen maintained at 720 ml of pressure. This is your first problem. So what is the volume of nitrogen which was given here? 450 ml. Okay, and what is the pressure of nitrogen? That equals to 720 ml. Okay, and one more here. What is the volume of oxygen which is given? 300 ml. Okay, and what is the pressure of oxygen which was given here? 600 ml. They are kept in 1 liter flask. So what is the final volume? Capital V equals to 1 liter. 1 liter means, shall we write it as 1000 ml because it was given in ml. Okay, here also 1000 ml. When they are kept in the container on top pressure, you need to this is the initial pressure. When it is kept in container, you need to find out what is the final pressure. Here also final pressure of nitrogen. Here the partial pressure, the final partial pressure of nitrogen. Here also partial pressure we need to find out. Okay, so what we can write here? P1 V1 equals to P2 V2. 450. What is the pressure here? 720 into volume is 450 equals to, you need to find out this one. What is the volume here? 1000. So P equals to, what we can write? 720 into 450 divided by 1000. This one gets cancelled. Okay, 5 2s 5 9 to 36. So what is the partial final pressure? Partial pressure of nitrogen when it is kept in container. We are getting 324 mm of Hg. Okay, and this one you need to find out. Again, P1 V1 equals to P2 V2. Same. See, 600 into 300 equals to P2 you need to find out into 1000. Yes, P2 equals to 600 into 300 divided by 1000. Cancel, this one cancel. So here you are going to get 180 mm of Hg. So this is the partial pressure of nitrogen when it is kept in container. This is the partial pressure of oxygen when it is kept in container. So what we need to do, we need to find out the final pressure of the mixture. Final pressure as per the Dalton's law of partial pressure is the sum of their individual pressures. So P1 plus P2, that equals to 324 plus 180, that equals to 504 mm of Hg. And compulsory you need to be familiar with the units. You have to compulsory write the units when you are solving any problem. Okay, yes. Now coming to the Graham's law of diffusion. What do you mean by diffusion? Diffusion is nothing but movement of any gas from higher concentration region to lower concentration region. Suppose when you came home, okay, and your mother or someone is cooking some biryani. Okay, so like, will the biryani smell, will it diffuses and will it comes? Yes ma'am. Will it, can you able to smell it or not? Within some distance you can able to smell it, yes or no? Even the jasmine smell, or else when you lit an agarbatti and if you keep it at some corner, you can able to smell the agarbatti smell, yes or no? How it is happening? Because that gas, it is diffusing. Diffusing means it is moving from higher concentration region to the lower concentration region. That is nothing but diffusion. Okay, and what do you mean by effusion? Effusion means, if it is there, suppose if you are keeping in some gas in container and you have only small hole, through this hole the gas is coming out. What this hole is nothing but, or a hole or orifice we call it as, right? Whatever the gas which is escaping through small hole, it is nothing but your effusion. Clear? Diffusion means it is moving from higher to lower, and effusion means you are moving through the small hole. With pressure it will come up. Okay, that is nothing but effusion. Okay, now coming to the diffusion. Whatever the rate of diffusion, it is denoted by the letter R, and this letter R, it is inversely proportional to square root of the density. Okay, some formulas. And this rate of diffusion is inversely proportional to square root of the molecular mass, molecular weight. Suppose if pressure is there, we can write it as pressure by molecular mass. Okay, and this rate of diffusion is nothing but the volume by time taken. So we can write this is one formula, this is second formula, this is your third formula, fourth formula. Okay, suppose if we are talking about two gases, R1 by R2 equals to, yes ma'am, V1 by, if the time is same, V1 by T, V2 by T. Okay, we'll write this one. If the time is different, R1 by R2 equals to V1 by T1, V2 by T2. This is for two different gases. Okay, based on this formula. Okay, na? Yes, ma'am. Now, let me apply one formula here. One question I'll ask. Suppose if three gases or four gases, we'll take oxygen, we'll take chlorine. Okay. We'll take helium and hydrogen. Yes, ma'am. Which one has greater rate of diffusion? See, what is this molecular? So here we'll take this molecular formula because it is inversely proportional. As it is inversely proportional, for the gas which is having higher molecular weight will has less rate of diffusion. If we take molecular weight for oxygen, it is 32. Okay. For chlorine, it is 35.5. Yes, ma'am. And for helium, yes, helium it is 4. For hydrogen, it is 2. Okay, which one is having greater rate of diffusion? Greater rate of diffusion, I mean, this is having more molecular weight, so it will be less rate of diffusion. As it is having less molecular weight, it is having more rate of diffusion. Okay, clear everyone? Now, let me revise once again. Dalton's law of partial pressure is nothing but the total pressure which is exerted. If we take one container of chemically unreactive gases, the total pressure exerted is equal to sum of their individual pressures. And this formula you need to remember. The partial pressure, this is pure. Okay, na? This is the pressure which is exerted by pure nitrogen. And partial pressure of a molecule equals to mole fraction of A into total pressure. Capital P stands for total pressure. Okay, and or else mole fraction equals to partial pressure of gas by total pressure of the mixture. Okay, and diffusion means it is a movement of gas from higher concentration region to lower concentration region. Effusion means movement of gas through small orifice or hole. This formula you need to apply, and for the gas which is having higher molecular weight, the rate of diffusion will be less. Is it okay? Yes, ma'am. And that's all for video. That's all for today. And if you like my video, please do like, share, and subscribe to my channel. And this is my third video. Okay. Thank you, students. Bye.